This video lesson is to help you recover the parts of the atom standard that you are missing currently. We are requiring you to watch the video, do the guided notes. You are to do the activity that's assigned as part of it, and this will allow you to retake the mastery quiz for parts of the atom. So what do we want you to know about atoms? We need you to be able to determine the number of protons, neutrons, and electrons for an element. You need to be able to model atoms using drawings with proper labeling, and you need to be able to explain the role of subatomic particles in the determination of an element. Let's start off with what is matter. So matter is what everything in this world and the universe and the galaxy is made up of. I have two pictures here. One is of gold bars, and then we have three dogs that are also pictured there. Those are all made up of atoms, and specifically they are all considered matter. Gold is an element, and so it is only made up of one type of atoms, whereas the dogs are made up of compounds and multiple different elements and lots and lots of atoms. The periodic table to the right is an organization system for how we can identify different elements. It is organized around patterns that exist for physical and chemical properties, but also patterns that exist based on the subatomic particles that make up the atoms of different elements. And so this is going to get us into our next part here, and that is what exactly is matter made up of? And it's made up of atoms or elements. And these can be organized into 118 different elements on the periodic table. To start us off, when identifying different elements, what we're looking at is the number of protons that an atom has. There's a total of 3 different parts for an atom that are all important for determining the type of element it's going to be and how it will react and what it will look like. Here are the 3 parts or subatomic particles for an atom. You have protons, which have a positive charge. They are found in the nucleus, and they have a mass of 1. You have neutrons, which are neutral in charge. They are also found in the nucleus, and they have a mass of 1. Electrons are negative in charge, and they're found in the electron energy levels around the atom, and they have a mass of 0. So all 3 of these are important for the type of element that you're dealing with and ultimately what it's involved with as far as matter goes. And so here's the subatomic particles and why they're important. The protons determine the element. All right. So for example, lithium, all those atoms have 3 protons. If it has more than 3 or less than 3 protons, it's a different element. The electrons are opposite in charge of the protons. They balance out that positive charge, but they're also responsible for the chemical behavior of an element. Neutrons are important for stability or lack of stability of atoms, and they're important for isotopes. We're able to model atoms and elements using the following picture here. There are 4 circles that I'm going to be drawing here. So we got 1, 2, 3, and 4. What each of these circles represent is we have the nucleus. We have our first electron energy level. We have our second electron energy level, and we have our third electron energy level. Now, when representing protons, neutrons, and electrons that were established on the previous slide, what we want to take into consideration here is we want to make use of the symbols. So, for example, protons are going to have a positive charge, and they're going to be found in the nucleus. Neutrons are found in the nucleus also, and they have a charge of 0. They have no charge. They're neutral. Whereas electrons have a charge of -1, so we represent those with an E and a minus sign next to it. If we're looking at just the electron energy levels now, okay, and so I'm going to draw the circle again here. The first can have a total of 2 electrons. The second can have 8 electrons. And the third can also have 8 electrons. Now, if you look at the periodic table, there's 118 elements. This, when you add up all the electrons, it gets you 18. You can continue to do this for all 118 elements. It's just not as easy. So if we're to do an example here, let's say I pick lithium. Alright, now lithium has 3 protons, and we can find that on the periodic table. It also has 3 electrons, and then it has 4 neutrons. So when we go to draw this now, we're going to put a 3 and a plus in the middle for the protons, a 4 and a 0 for the neutrons. And then we're going to place the electrons, starting with that first energy level, fill that up, and then work your way out. Now, before we said 2 can go in the first, and then we have a maximum of 2 there. And we said the second shell can have 8. Well, I only have 1 more that I need to place in that second shell, so I'm only going to place 1 of the total 8. How do we go about determining the number of protons? The protons are determined by the atomic number. So, for example, here's helium from the periodic table. Okay. And so the protons is determined by the atomic number. Okay. In the packet there, what you're being asked to do is you're going to be asked to identify the number of protons for a series of elements. So go ahead and pause the video while you go ahead and do this. Continuing with this, the electrons are also the same number as the protons because they are equal and opposite charge. So electrons are also equal to the atomic number. And so again, go ahead and pause the video. You're to answer the questions that are in the packet. The last part that we have to figure out is that of the neutrons. And so we established before that protons and neutrons have a mass of 1. Electrons have a mass of 0. And so this bottom number here is the atomic mass. Okay, and so we're going to round that to the closest whole number and subtract the number of protons to figure out neutrons.
Just pardon the interruption. All those students that are going on the field trip with Mr. Judson and Ms. Goldsmith need to report to the guidance office.
Neutrons
if they have not had their picture made, they need to do so immediately.
Equals.
All those students report to the guidance office. Thank you.
Rounded atomic mass minus atomic number. And so we're going to ask you to do the following problems in the packet to answer that question. To finish up this recovery assignment, there are a series of problems that you need to go ahead and figure out the number of protons, neutrons, and electrons for. Upon completion of the activity in the poster, you will be able to retake the mastery quiz.